Hi, welcome to the second lesson on static electricity. In this lesson, we're going to learn about the dangers and uses of static electricity. Now, before we move on, please do pause the video and take a moment to take these tables down. Fantastic. I hope you've got both of these down. Now, the first danger of static electricity is lightning, and it's a perfect example. Let's take a look. So, how does lightning actually form? Here we have some clouds. Now within these clouds, there's a lot of friction between the water and ice droplets at this high altitude. As a result of this collision within the clouds, there's a lot of friction. And as we saw in the last lesson, this friction causes electrons to be removed from the atoms and a negative charge is induced at the bottom of these clouds. And as we have negative charges here, positive charges begin to form on the land as positive and negative charges begin to attract each other. The induced positive charge on the ground creates an electric field. It's attracted to the electrons in the cloud. When this electric field, when this attraction is large enough, we get lightning, like so. And as we get lightning, you all know we have thunder too. Here's a fun fact about it. Now this is what lightning does to a tree when it's struck. It catches fire and is often blown up, and it has a similar effect on houses, as we can see here. But this doesn't happen all the time. So we can see here, this is the Empire State Building in New York. Why isn't this building on fire? Why hasn't this building blown up? Why was it not destroyed? In fact, most buildings have a sort of protection against lightning. This is called earthing, where we have a lightning rod that carries lightning directly from the top straight to the ground. This material is often a conductor, an extremely good conductor, which carries the lightning away from the building and straight towards the ground. This prevents the static buildup of electricity, and we have current flowing through instead. This protects the building, as the energy and the electrons do not come into contact with the building. They just pass straight down. So this is what your table might look like so far. Let's move on to the next one. Here we have a car and a plane. Based on these images, how do you think static charge builds up on their bodies? Pause the video and think. As we can see, this car and this plane is exposed to a lot of wind. And this wind creates a great deal of friction. As we saw, this friction causes a negative charge to build up on each body, on both the car, as we can see here, and the plane. And the charge doesn't transfer to the ground, as we have the tires made out of insulating material. The tires are made out of rubber, obviously. So the charge remains on the body of the plane and the car. Now this isn't often extremely dangerous, but it can be dangerous, like we see here. This is a fairly large zap, but more often than not, these are very small releases of charge. This is what the table might look like. Often in aeroplanes, especially when there's a lot of charge built up, the plane is earthed to the ground on landing. This prevents the charge building up and causing too many sparks. Now let's take a look at fueling stations. In this case, we see fuel flowing through the pipe into the fuel tank. Now, as this flows through, it rubs against the material on the fuel tank. This friction causes charge to build up. As this charge builds up, we risk sparks forming. And as these sparks form, especially with the fuel being so close, this often results in large fires like we can see here. This is actually why telephones or mobile phones aren't allowed in fuel stations, because they risk sparks forming. Pause the video and correct your table for the dangers in fueling stations. Now let's move on to the uses of static electricity. We're going to focus on printers and painting cars. Let's look at printers first. Have you ever wondered how the ink moves from the printer into different shapes and letters on the page? Static electricity actually plays a large part in this, as we can see here. The ink from the printer has a certain charge. In this case, it's positively charged. And the droplets flow from the ink nozzle onto the paper. However, their position is dictated by a negative plate and a positive plate. The more negative it is, the further the ink droplet is going to land. Now, this can be controlled extremely precisely by changing the voltage of the plates. This allows us to write different letters and form different shapes on the page. So remember, the ink is given a static charge, and the plates allow us to guide that ink into different positions. Now let's move on to the painting of cars, and this is potentially the largest application of static electricity. Have you ever wondered how they're able to get an even coat of paint on both sides, even though the man is only standing on one side? They actually use static electricity to help. Let's take a look. Incredibly, they were able to get an even coat of paint on both sides, even though the man was standing on one. Whether you look at it from this side or the other side, the coat of paint is essentially the same. So, in this case, the paint is often negatively charged, and the material, the metal, is positively charged. This allows us to paint all around the material, even if we're just painting from one side. This is how cars, bikes, and almost everything is painted. Now our final table will look like this. I hope you found this lesson useful. If you have any questions, please do ask.